In this tutorial we are going to create an external gear pair which is going to be controlled by a motor and will be part of the first part of your homework 1E for problem number 1E and homework number 2. Now to do this, what we'll start off with is, after opening working model, we'll go to the view and then workspace. And then we'll click on rulers, grid lines, and XY axes, and that will enable us to get a good feel for where we are in the workspace. Now as you view the video, you may actually find that you have to scroll up and down, similar to how you scroll up and down in any normal application, to be able to see the top menus and also the bottom menus, because now my cursor is disappearing, so you're going to have to scroll down to be able to see the bottom part of this. But at any rate, back to our task at hand, is we now have the workspace shown, and what we want to do is create this external gear pair. So we're going to start off by creating our gears in terms of these circles. So come up here to the object list and click on circle, and then we'll click on the workspace and just drag down and then release, and now you have created a circle which will be our input gear. Now at the bottom, remember, scroll down, at the bottom we have the X, Y coordinates of the center of this disk, so we could actually change those, let's say to X equals 0. I'm going to leave the Y the way it is for a second. And then the radius here is, we want the radius to be 0.5 for our homework problem, so let's just go ahead and type in 0.5 for R, and there we have the disk at the right size for our problem. In addition, down here you can see that there is an angle display, and we could change this to change the input angle. That would be at 1 radian, so you see the reference line for the circle, but let's go back and just put it at 0. So it's now, the reference line for the circle is lined up with the global x-axis to start with. Now what we want to do is we want to drive this input gear using a motor. So let's go down to our constraint, one of our constraint blocks down here, and select motor. So I select motor and then bring motor over to the disk or the circle, and notice that when I move it towards the center you get this X mark. Well, it says that it really wants to just snap connect to that location, which is what we want. So we now have the motor attached to the gear, and if we were to double click on the motor, just like if we double click on any object, that will open up the properties window. You can also get to the properties window by going up to window and then down to properties, but we already have it. So here you see in the properties window for the motor, we have the type of motor. Well, we can have a torque motor, rotation motor, angular velocity motor, and acceleration motor. We want the velocity motor, which is what it was set at. And then you have the value here. So you could just change the value here to change the value of the input speed if you liked. However, what I would like to do is actually control this motor. But first, before I do that, note that what I want is to make things simple. I'm going to go ahead and put the Y coordinate of this motor to be 0, as is its X coordinate. So I can now, with the motor, I can move the motor around, which will move the disk around as well. So I can come down to Y, type in 0, and now the motor and the disk move up to the coordinate 0, 0. Okay, now I want to command this input velocity. I want to make that transparent to the user. So we can do that by clicking on the motor, then going up to define, and from define come down to new control, and note that we have the same type of controls for the motor that we had before, and we select rotational velocity. Now the control that comes up is what's called a slider control, and you can move the slider up and down and it'll change the value for the velocity of the motor. But what I prefer to use is the text box type. So if you didn't have the properties window open at this stage, you could again double click on this object. It opens the properties window for the slider input. Well, let's change it to text box, change to a text box, and then we have the opportunity to set the minimum angular velocity, and let's let that be, say, -10 radians per second. Our units here are SI units. That's the default for working models. So those are radians per second as the minimum being 10, and then let's set 10 radians per second be maximum. Okay, so we can come in here and select this. For our homework problem, we want the input speed to be 5 radians per second. So I'm just going to type in 5. So there we have it. Now I also like to work with the appearance of things, so we can go to Window, down to Appearance, and open the Appearance window, and then if I click on this input, it now opens up. I could actually change its color if I wanted to, but let's leave it as black. But what I want to do is change its name, and I want to just simply say that this is the motor's angular velocity, and I'm going to abbreviate velocity. So there, you can change that name to be anything you want. So here's the angular velocity. I'm going to move it within on the workspace to locate it where I want it. And now if I run this motor, you can see that, okay, it's running fairly fast. That's 5 radians per second. But I can also change it. And let's just show you, let's say -3. So now it should rotate in the clockwise direction, and there it goes. It's clockwise. But our input, our homework problem says we want a counterclockwise 5 radians per second, so +5 radians per second. Okay, so we've got that. Let me go ahead and close these windows up here at this stage, and now I want the second gear. So I'm going to click on the circle again, then click and drag on the workspace, and there's the second circle. Well, how about that? I got a radius of 1, which is what I want, but notice that you can have it, whoa, way big. Let's just make it go back to 1. So there it is with a radius of 1 that we wanted. And now we want it to be touching the input gear so it looks like a gear pair. So we have the radius of the input gear is 0.5 meters, the radius of this gear, the second gear, is 1 meter, so the center of this circle needs to be at coordinates 1.5 in the x direction and 0 in the y direction. So again, selecting the gear, come down to x, type in 1.5 for x and 0 for y, and now we're set up where we need to be. But if I was to run this right now, that second gear would fall because it's not constrained to ground. So I need to connect this to ground, and I'm going to do that using a pin joint. So here's the pin joint. Select the pin joint. Again, it's going to snap on when you get it close to the center and just click. So there it is. Now if I run, what's going to happen? Well, the input gear, input disk is running, but this output disk is doing nothing. That's because we haven't told working model that these are gears. To do that, you come over to the left and you select the gear icon, click anywhere on the input gear and then anywhere on the output gear, and now you have 2 external gears in contact. And you can see that they're external gears because the teeth are on the outside. So if I run this, you can see sure enough the output gear is rotating in the opposite direction as the input gear. But I want to be able to measure that velocity, so to do that I can click on the output gear and then go up to measure, and then go down to velocity, over to rotational graph, and out comes a rotational graph, and then I can run and you can see there's the angular velocity. But what I want, since it's constant, I don't really want the graph, I want a numerical output. We also have a output that's a bar, kind of like a colored bar. Well, we don't want that either. What we want is this numerical output, and if we now run, you can see that sure enough we get the output velocity being equal to negative, so it's rotating in the clockwise direction opposite the input gear, and it's rotating at half the speed, which makes sense because the output gear is twice as big as the input gear. We will continue with this in our external gear pair 2 tutorial.